Spectra. The meaning for the word spectra is a colored picture. Don't be confused. Colored picture means it is not in colors. Frankly speaking, it is just like a screen having some lines. Then why it is called as spectra, a colored picture? Though it is a black and white, we call it as a spectra. Here, each line stands for a specific color or a specific wavelength. That's why it was called as spectra. We mostly depend upon this spectra. So, it is essential for us to learn about some basic things regarding the spectra. How the spectra is forming, what it is indicating, etc. So, let us recollect the terms. Dispersion of light. We already discussed about the properties of light. Properties of light means the velocity of light, wavelength, frequency, amplitude, wave number, and so on. Now here, that light which is emitting from the sun is appearing in white color, but actually it is not in white. This white light, when we allow to pass through a prism, it was split up into different colors. The splitting of white light into different colors according to their wavelengths is said to be dispersion of light. When this dispersed light was recorded on a photographic plate, in that photographic plate you will find some group of lines. So, such group of lines, each line indicates us a specific wavelength. Each line indicates a specific wavelength. That is called as spectra. That is called as spectra. These spectra are very much useful while studying the structure of an atom or the position of an electron in an atom. The position of electron in an atom. Now, let us see how these spectra are recording. So, when this phenomena is called as dispersion of light, when light is dispersed, that dispersed light was recorded on a photographic plate, the image thus obtained is said to be spectra. The instrument used to record the spectra is said to be spectroscope. The instrument which we use to take photographs is said to be camera. Just like that, the instrument which was used to record the spectra is said to be spectroscope. Now, how these spectra are recording? Let us see how they are recording. Now, we have already discussed that light has property to diffuse like this. Now, in an atom, the electrons are at specific positions. Basing on the position of electron, atoms have tendency to absorb any one color of this light. With the help of that, we can assume or estimate where the electron is present, basing on the color that was absorbed by the atom, or basing on the wavelength of light radiation that was absorbed by the atom, we'll get a definite spectra, a different spectra. So that is the way we are going to know about the position of an electron. Now, before this white light entering into a prism, what we'll do? We'll take a sample of gas which is under study. This sample of gas, through the sample of gas, we were allowing this white light. Now here there are so many atoms present here, a group of atoms belonging to the element which is under study. So basing on the position of electron in that atom, these atoms will absorb a specific wavelength of light radiation. A specific wavelength of light radiation was absorbed by these atoms. And all the remaining wavelengths will be transmitted out. So, before this light entering into the prism, suppose if this wavelength was absorbed, what happens? This line in the spectra will disappear. Because of that, there will be a gap found here. So all the lines will appear in the spectra except the line that was absorbed by these atoms. So this spectra was recorded while atoms are absorbing energy. That's why we call it as absorption spectra. In absorption spectra, you will have a bright lines on black background. In a black background, you will find some bright lines. Now, if we stop the light source, focusing on the atoms, now what happens? Before this, these atoms will absorb some wavelength of light radiations. When this light is cut off, these atoms, which are in excited state, will come to the ground state. When they are come to the ground state, they will emit energy in the form of light radiations. Now, here, the wavelength which was absorbed here will be emitted out. So, if you record the spectra, while atoms are emitting energy, that spectra is said to be emission spectra. So, that means here in this spectra, you will find a white line on dark background. So both these spectra, whether it is, so here when white light is allowed to pass through an atoms, a sample of atoms which is under study, basing on the position of electron in those atoms, these atoms will absorb a specific wavelength of light radiation. A specific wavelength of light radiation was absorbed by these atoms. So when we record a spectra, that wavelength is disappear from this spectra, which was previously observed. There will be a line here. But when the light was passed through the sample of atoms before they enter into the prism, then one or two lines will disappear. Those lines indicate the wavelength of light radiation that was absorbed by those atoms. By that way, we can estimate the position of electron in that atom. So this spectra was recorded when atoms are absorbing energy. That's why it is said to be absorption spectra. It is said to be absorption spectra. In absorption spectra, you will find a black lines on white background. You will observe a black lines on white background. That black lines indicates the wavelength of light which was absorbed. Now, when the source of light was stopped, these excited atoms will reach to the ground state. Then they emit the same wavelength what they have observed previously. If that wavelength of light radiation was allowed to pass through the prism and spectra was recorded, then you will get another type of spectra which we call it as a emission spectra, because this spectra was recorded when light was emitted by the atoms. In emission spectra, you will find a bright lines on dark background. This spectra is said to be emission spectra, whether it is an emission spectra or an absorption spectra. Both these spectra will indicate us what wavelength of light was absorbed or emitted by these atoms. Basing on that, we can estimate the position of electron in an atom. This is regarding the spectrum.